this is a video on the introduction to limits. So the first thing we're going to do is we're going to fill out these tables for 3 different functions. So we're going to start with f of x, which is just your general linear function, x plus 3. So first I'm going to go to my calculator and just take a look at what this looks like. X plus 3. And this is just your general linear function, slope of 1, y-intercept of 3. So let's fill in our table. So what happens when we take 3 and plug it in? What's 3 plus 3? 6. As I start to move away from 3 and start to put in numbers that are smaller than 3, like 2.9999, 2.999, 2.99, 2.9, getting further and further and further away from 3, getting smaller. My 6 starts to also get smaller. 5.9999, 5.999, 5.99, 5.9. As I start to get a little bit bigger than 3, my y value starts to get a little bit bigger than 6. If I add 3 to 3.0001, I get 6.0001, 6.001, 6.01, and 6.1. So as I move to the right, as I get bigger than 3, I get bigger than 6. If I get smaller than 3, guess what? I get smaller than 6. So let's see what that looks like on the graph. Oops, not that one. So right about, let's see, 3, 6. It's right about here. Oh, I didn't mean to do that. I have to fix that. Okay, 3, 6, right about there. So if I look at all of these ordered pairs that are right here, and right here, and right here, and right there, and right there, and right there, they're kind of all following this pattern. If I didn't have anything right here, and I said, what would this be? Pretty sure you could fill it in. You could be like, well, here's the trend. It's coming up, it's coming down. That's the only logical thing that we could have right there. Of course, it's a line. It's going to just keep continuing. We call this a limit. So we look at it from the negative side, from the left, and we look at it from the positive side, from the right, and we notice that they're both going to the same place, to 6. And that's our limit. The way that it's written is the limit of f of x as x approaches 3 is 6. And all that means is, as we get closer and closer to 3 from being less than 3, we're getting closer and closer to 6. And as we're getting closer and closer and closer to 3 from numbers that are bigger than 3, we get closer and closer and closer to 6 again. So let's look over here at g of x. X squared minus 9 over x minus 3. So this is a rational function. You may have remembered these from earlier in the year. And rationals look something like that, or like that. Sometimes we have those slant asymptotes, and maybe here and here, something like that. So x squared minus 9 over x minus 3. Let's get that on the graph. X squared minus 9 over x minus 3. All right. So not exactly what we were expecting, right? Why? What's going on with this one? Why is it a line? Let's pull up our table maybe. Control T. Ooh, something's going on at 3. Do you remember what that's called? Let's go to trace. Going up, going up, going up. Oh! Nothing there. Remember, it was called a hole. So, You might look at this numerator and say, I think I see something going on there with that difference of squares. So x squared minus 9 factors into x minus 3x plus 3. And remember, when that factor cancels, that's when we have a whole. So let's check this out. What's going on here? If I plug in a 3, and I take 3 squared minus 9, 3 squared minus 9, that's 0. Plug in a 3 to the denominator. 3 minus 3, it's also 0. This 0 over 0 is called the indeterminate form. Indeterminate form. It means that something crazy is going on here, and we got to figure it out. So I can't directly plug in a 3. That's undefined. Doesn't work. So what I need to do is I need to see what we're approaching from both sides. So what happens when I plug in a 2.9? So 2.9 squared, of course we all know that. Just kidding. 2.9 squared minus 9. And then I'm going to divide that by 2.9 minus 3. So of course I'm just using my calculator here. So I'm taking 2.9 squared and subtracting 9. And then I'm taking 2.9 minus 3. That actually gives you 5.9. And you can plug all of these in the calculator to verify, just plugging into G. It actually gives you the same exact thing. Oops, missed a 0. So why does that happen? Well, if you look at this graph, this basically looked exactly like what we were looking at before. It just looks like a line. There's just a hole there. The limit still exists. Let me clear this stuff for a second so we can actually focus on the graph. The limit still exists because what we're saying is, as I go here, what am I approaching? As I get closer to 3, am I not getting almost to 6? Look at it. Oh, it's doing this on its own. Oh, crazy. Okay. Back to me. So as I get closer and closer to 3, here I am. Look at this x value. I'm talking about this right here. 1.2. Look at my y. 4.5, 4.8. Oh, I'm getting close to 6. I'm getting close to 6. But not 6 exactly. I'm almost there. 2.7, 5.7. Pretty much 3.6, right? If I go up here, and I come down towards 3. So be looking at this, 4.8, 4.5, 4.2. Look at my y value. Isn't it getting close to 6? But it doesn't actually touch 6. And that's okay. It doesn't have to. We would still say that the limit of g of x as x approaches 3 is still 6. If you look at the trend, getting closer to 6, 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 getting closer to 6. It doesn't actually go to 6, but that's okay because this is the limit. This last one's also a rational function, 1 over x minus 3. And this is going to look a lot more like what we were anticipating. 1 over x minus 3. But what's going on at 3? If I look at my table, I'm still not defined at 3. Why? That was called an asymptote. Notice they're going off in different directions. That's important. So let's plug in a 3 exactly. What's 1 over 3 minus 3? Undefined again. But can I plug in a 2.9? Sure. Let's use our calculator. 1 over 2.9 minus 3. 1 over 2.9 minus 3. That's negative 10. 1 over 2.99 minus 3. That's negative 100. This becomes negative 1,000. This becomes negative 10,000. Okay, weird. Not the same thing as what we had before. Let's plug in 3.0001. So 1 over, well, I'll start with 3.1. That's easier to write. 3.1 minus 3. 1 over 3.1 minus 3. That's 10. This is 100. This is 1,000. This is 10,000. Look at the trend. Remember this one? We were like 5.9, 5.99, 5.999, 5.99996, 6.001, 6.001, 6.01, 6.1. It was like, yeah, duh, it's going to be 6. Here, this was just a hole. Like, it looked like it was just all in a straight line. This one is where the limit doesn't exist. Why? Well, they're going off in different directions. When I look at this and I say, as I get closer to 3, this one's going up. As I get closer to 3, this one's going down. That's not the same number. So we would say that this one, the limit does not exist. Mean girls, the limit does not exist. So why? You're not really approaching a number. As I get closer and closer to 3, this one's going down. As I get closer and closer to 3, this one's going up. So we would write that the limit of h of x as x approaches 3 does not exist. So they want us to kind of summarize what happened over here. X plus 3 was just a line. Looked like that. When I went to 3, we had the point 6. Easy. X squared minus 9 over x plus 3 actually also looked like a line. However, there was a hole. Right there. But the limit still existed because as I get closer here and as I get closer there, I'm still going to the same spot. I'm still just missing a little piece. This one though, limit does not exist. This part came down, this part came up. You have an asymptote. So being defined at a number and having a limit being defined at a number are two different things. So just saying f of a means something different than saying the limit at f of a. F of a actually means the y value at a certain x value. It just actually means the filled in dot. The limit is what you are approaching. And you've got to do the same number from both sides. From the positive side, from the right, and from the negative side, from the left. So if we look here, f of a exactly is 2. But what are you approaching? From the left, are you getting close to 2? And from the right, are you getting close to 2? So that means the limit's 2. But look at this one. Exactly where am I at A? This is an open circle, so I'm actually up here. This is 3. But I'm going to say that the limit doesn't exist because from the left, I'm approaching 2, but from the right, I'm approaching 3. So the limit doesn't exist. We're looking for that closed circle again because this is not where it is at A. It's up here. That's 3 again. And again, I would say this limit does not exist because from the left, we're going up to 3, and from the right, we're coming to 2. Now this is a creepy one. Everybody always gets confused on this one. Actually, where am I at A? I'm at 1. This is called a removable discontinuity. But where am I approaching? 2. All right, catch the rest in the last video. Next video, I mean.